Hello guys, welcome to 5.3. We're looking at definite integral as area. Now in 5.1 and 5.2, we looked at some introduction of area under a line, right? Which we are trying to approximate using rectangle areas, right? Trying to approximate what the area under the curve is. Now, of course, depending on whether you use the left sum or the right sum, we will get either an overestimate or an underestimate. So in 5.3, we're going to look at the technical part of integral, right? Which is what we have here. Right. So let's look at the definition first. When f of x is positive and a is less than b, the area under the graph of f between a and b is given to us in this form. Okay. So this notation is the integral. Right? So integral from a to b of f of x represents the area under the function f between a and b. Right? So as we can see in this graph, right, we have a and b right here, which are just two x values, which we want to use them as bounds. Right? A is the lower bound and b is the upper bound. So on the area under the curve, which is this blue line f of x, and the area between a and b can be represented using the integral of f from a to b dx, right? And the dx here represents the independent variable. Okay, so this whole thing can be read as the following. Integral of f of x from a to b. And again, where a is your lower bound, right, lower bound, and b is your upper bound. Okay. And as you can see that on the left picture, the picture on the left, this is what we were doing in 5.2, right? We draw different rectangles and try to fit them under the curve and then calculate the area of each rectangle by adding everything up, right? Remember the width of the rectangle is called the delta x, right? And the number of rectangles we have here is the n, right? So being able to evaluate integral will give us the exact area under the curve, which is pretty nice, right? We don't have to guess the area under the curve anymore. We won't run into any overestimate or underestimate. We will be able to get the exact area under the curve, right? So before we talk about the actual way of integration, let's look at some example together. All right, let's take a look at this problem together. We want to express the blue area using the integral. Right, so we have this function right here, f of t, which is 2t cubed minus 2t plus 3. And we're looking at the x value. So we're trying to find out what this value is and this value. Right, those are our a and b, our lower bounds and upper bounds. So it looks like the lower bound is about -1, and then upper bound is about, let's just say 0.5, right? Or 1/2. Okay. All right. So to express the area under the curve, first we need the integral, right? That's not the best integral symbol, right? And then usually I like to start identifying the lower bound and upper bound. So lower bound is -1, upper bound is 1/2, right? Just like that. And then the actual function, which is parentheses, 2t cubed minus 2t plus 3. Now notice that here the independent variable is t. So at the end, we have to add a dt. Okay, and that's it, area. Okay, so keeping track of the independent variable. Now this is where we will see um, something called negative area, probably for the first time. Now, usually when we talk about area of like a square or a triangle, right, they are always positive, right? But when we are talking about integrals, when we are talking about area under curves, they can be negative, right? So let's see. The integral of f of x from a to b is the sum of the areas between a and b above the x-axis, counted positively, right? So if it's above, it's positive. And the areas between A and B below the x-axis is counted negatively, right? So if your area is above the x-axis, then it has a positive area. If it's below, then it's negative, right? So let's look at these three um, example, right? It tell us the area under the curve, right? The actual area, and we want to write out what the integral is going to be, right? So the first one is from 0 to 5, right? So integral from 0 to 5 of the function f of x dx. It tells us that the area is 8, and this area is above the x-axis, so it's a positive 8, right? Now for part B, right, we have the same thing, integral from 0 to 5 of f of x dx. Now it tells us that the area is 6, but notice that this area is actually below the x-axis, so it's going to have a negative area, which is going to be -6. Now, something a little more interesting, right? We look at part C. We have the integral from 0 to 5 of f of x dx. Now notice that between 0 and 5, we actually have two different areas, one above the x-axis and one below the x-axis, right? So to find the total, we just need to add both of them together. Now the one that has area of 10 is above the x-axis, which is this part, right? That's gonna have positive area, so a positive 10, plus the one that is below the x-axis, which is this part right here, it's going to have negative area, right? So we have to add -3. And by adding these two values together, we get that the total area under the curve is +7. Now I know it's not making a lot of sense, right? Because how can you have negative area, right? So this is how we define areas under the curve, right? If the area is above the x-axis, then it's positive, like what we have in case A. And if it's below the x-axis, then it's going to have negative area, like in part B. And sometimes we will get both of them at the same time, which is part C, and all we have to do is add them together. And of course, you have to take account into the sign of the area. Again, positive if it's above the x-axis, and negative if it's below the x-axis. All right, so here we have another example with actual numbers, and let's take a look at them. All right, so the function f, right, has a curve like this between x equal to 0 and 4. So to represent the area under the curve from 0 to 4, right, we're looking at integral of f of x dx from 0 to 4, is basically the sum of these two areas, right, a1 and a2. Now we also need to take into account that since a1, that's above the x-axis, it's going to have positive area. A2 is actually below the axis, so it's going to have a negative area, right? So in this case, we're going to do a1 plus a2, which is going to be 7.72 plus negative 5.05, which comes out to be 2.67. Okay. So this is the interpretation of the integral right here. All right, interpretation of integral using area. Now, sometimes they will ask you another type of problem that, in my opinion, is a little tricky. It says find the total shaded area. Total shaded area. Now, in this case, we are not worrying about integrals, right? We're not talking about areas under the curve. All we are actually worrying about is what are the shaded area, right? So in this case, we don't have to worry about having negative area because it's on below the x-axis. All we need to do is just take a1 plus a2, which is 7.72 plus 5.05, right? And that will give you 12.77, right? So very different interpretation between the two, right? Here we are only focusing on area, whereas in the previous example, we are understanding this as integrals. Okay. Now, another way that we can look at area under the curve is we can actually look at area between two functions, in this case, f and g, right? So all we need to do is take, to find the area between f and g, we just take the area under f, subtract the area under g, right? So the area under f can be represented as integral of a to b f of x dx, right? And minus the area under g, which is the integral from a to b g of x dx. And to simplify it even further, right, we can actually combine them into just one integral going from a to b of f of x minus g of x dx. Okay, and this is how you find the area between any two given functions. Of course, with a and b being our upper bound and lower bound, and they both have to share the same upper bound and lower bound. All right, so let's look at this example. Use a definite integral to estimate the area enclosed by the graphs of these two functions. Okay, so whenever you are looking at areas between two functions, you have to identify which function is on top and which function is on the bottom. Because to find the area between area between two functions is always the function on top minus the function on the bottom. Now, of course, within the range, right? So in this case, we are looking at the blue shaded area. So we're looking at from 0 to 3.12. Okay, so we are only focusing between these two values, 0 and 3.12. Okay, so the function on top, which is this one, right? That is f of x, right? And the function on the bottom is g of x, okay? Between 0 and 3.2. Now you can see that after 3.2, the function on top becomes g of x and the function on the bottom becomes f of x, right? But since we're only worrying about between 0 and 3.2, we are going to use f of x as our top function and g of x as our bottom function. All right, so let's write out what the integral will look like. All right, so going from 0 to 3.12, top function minus bottom function. So the top function is f of x minus g of x dx, right? And that's actually replace f and g with their respective expression, right? So that's equal to the integral from 0 to 3.12. F of x is 4x minus x squared minus g of x is 1/2 x to the power of 3 over 2. All right, and go and put that in parentheses, dx. Okay, and to actually find the area, since we haven't talked about any techniques for integration, we can actually use uh, some online calculator, or if you have a graphing calculator, you will be able to do calculations using a calculator or some online website. Now, if you want to try this out, you can go to Wolfram Alpha, wolframalpha.com, and then type in the following: integral, and then for x minus x squared minus 0.5x to the power of 1.5 from 0 to 3.12, right? And then you can, once you type that in, press enter, then they will give you the graph, and they will give you what the area under the curve is, what the area between these two functions is going to be. All right, if you want to try this out, right, feel free to pause the video and try it out. And after you type into Wolfram Alpha, you will see this definite integral notation. So it tells us that it's a 5.90615. So that's the area between these two functions, f and g, between for x between 0 and 3.12. Wolfram Alpha is a really nice website, one of the most powerful online calculator there is today. Right? So feel free to play around with that. They work with integrals, they work with derivatives as well. All right, and that's it for 5.3. Now, we actually haven't talked about any integral techniques. Like how can we perform integration by hand? Right. So for now, there are some questions that requires you to use either a computer or a calculator to evaluate integrals. And feel free to use Wolfram Alpha or your graphing calculator if you have TI-83 plus and above. Those will do integrals fairly nice. You just need to learn how to use your graphing calculator to evaluate integrals. And there are a bunch of YouTube videos, online readings, topics, and that will show you how to use your graphing calculator. All right, and that's it for today. Thank you guys very much. I'll see you next time.